is going to work. Another thing that came up was why I was wondering when and why someone would want to execute code inside of the main. So the idea of the main in general is you're just going to execute uh, functions or methods. So your main, you're not supposed you're right in a matter of you don't need to write the code in the main. So main is just going to be executing your methods. So if I take those methods and put it somewhere else, and we're going to practice on those things, we're going to go over the classes and different files and those kind of things. So you can think about your main is going to be testing your method, or the things that you cannot do or don't want to do it in the method, you take it and put it in the main. So if I was writing a math module, I would have main be the test I wanted to run on my code. Well, that which is true. This is the reason that I thought of and was wondering if there was. So another thing that you want to think about the main is in Python, because it is a scripting language, it has to see a method before it be able to execute it. So if you don't have a main, that means you cannot call a method in another method if it hasn't shown up yet. So if you want to call any method, it has to seen it before. So you have to have the actual method before you be able to call it. And sometimes when you want to call a method inside another method and you want to call another method, that's going to get a little confusing because Python is not going to be able to execute a method if it hasn't seen it. So the way that this book is organizing it, and a lot of people are doing it, which I really like it, is you create a main, but when you execute your main, that's the time that it has seen all the methods. So you can call the methods in any order that you want. If you don't have a main, you have to call the methods in the order they show up. So that's another concern about having a main. But I do agree with you that we shouldn't have too much of code in the main. It's just executing the methods. So if you're thinking about top-down design, you take your big task, you break it down to the smaller tasks, and your main puts those smaller tasks together to create a program. So that's the idea. So with the recursive code, again, we're going to go over it the next week. But the concern on the recursive, I gotta be honest with you. I was scared of the recursive. I did not want to do a recursive. I got away with it throughout my whole career. I did not do any recursive. But on the other side of it is I was in the business area, not the scientific area. So it does take a lot of memory, and not necessarily it is best. At the beginning, it was interesting for me because you write less code to do a lot more work. But on the other side of it is it's going to use the memory. So we got to find a balance. So the rule of thumb for me would be if I can write it in a loop, I'm going to write it in a loop. So if I can get it done with a while loop or a for loop or something like that, I would do it. But there are some algorithms, and you saw some of them for those who were looking at it. Again, we're going to go back and we're going to look at it. So drawing some graph, doing some algorithm like a binary tree or those kind of things, the data structures, you cannot do it without the recursion. So there are some, for example, if you want to do a puzzle, if you want to solve a puzzle, or if you want to do certain things. So if you want to solve a movement in chess, so you would do the moves till you find out that it's a bad move, and then you have to backtrace it. We talk a little more about this next week. But that's the idea of the recursive. That's a good thing to know for the complex uh, things that we want to do. So for recursive, you have to have the first thing that you have to understand or I would want to do is where does it stop? So the idea of the recursive is what? The function is going to call itself. So if the function calls itself, that means if I don't have a stopping point, it's going to keep going. And because every time it calls itself, it puts the uh, code inside a memory location called the heap, if it keeps creating those things, eventually your computer is going to crash. Just like you had the C++ pointers not being handled, that's going to crash. So first thing first is where do I stop? If I have a recursion, what is my stopping point? It can be one thing, two things. I put those first, and then I go and call the function. So okay, something has to change. So my sub function is going to have a value which is going to be less than the previous one. So I'm going to take the same function, I'm going to call it with the smaller number. So if I want to do factorial 10, I'm going to call the factorial 9, and then I'm going to call factorial 8, and so on. Again, I'm going to go over it uh, next for the next week. We're going to do something next week with those things. So a lot of people are talking about the recursive. We're going to talk more about it next week. The software toolkits, we're going to talk about those also. I go over some stuff, and then especially the image processing, the graphic one. It's getting very popular for math area. So we're going to do those things. Well, these are the things that I found as I was going through your stuff. Oh, talking about the passing by value versus passing by reference. So if you pass an object, we haven't talked about this, but I made a note to talk about it anyway. So if you pass an object, the object is going to be passed by reference. It's going to have its address to be passed. Now, it does use copy, but when you're passing the object, it's not copying the object, it's copying the address of the object. Because somebody was asking, okay, if it's always passing by value, how is it that if you do graphics, it's going to affect? So if you have a primitive data type, that is not passed by object. But if you pass by object, like the one that we were doing in the previous chapter, you were learning about how to do classes and objects. And we're going to get a little more into it as we go forward. Then those are going to be passed by address. Yes, it does copy, but they copy the address. So inside of your method, you're going to have an address of the object that you're going to be using. And because you're using the address of the object, then of course it's going to have any changes you do is going to happen to the object. So that's another question that was there somewhere. What else? These are the things that I found out about your reflection. I appreciate for your class. I really, really like your class of being very active on the reflection. You guys have some very, very good posts and some very good responses. I just want to go over the areas that you said you have difficulties with. But if you have questions or concern about other things, let's talk more about it, and then we see how we're going to do it. Okay? So that's all I want to talk about.